All right, we're going to do some extra examples to get us more comfortable with vectors. So, if we let A equal 7, 4 and B equal 6, 3, we're asked to find the following. All right, so if we're asked to find A plus B, we know that that equals A1 plus B1, comma A2 plus B2. So, that's going to be 7 plus 6, comma 4 plus 3. And we're going to get that the vector AB is 13, comma 7. All right, now if we subtract A from B, we know that that's A1 minus B1, comma A2 minus B2. All right, which is going to give us 7 minus 6, comma 4 minus 3. And that is going to be 1, 1. Now we're asked to find the length of A plus B. Okay? Now we know that A plus B is 13, comma 7. So the length of this is going to be horizontal component squared plus our vertical component squared. Okay? And that is going to be about, let's go ahead and put this in our calculator, plus 7 squared. Oh my gosh, it's going to be this ugly number. All right, so that's going to be about 14.76. Now when we get down here, we're asked to find 2a minus 1/2 b. Okay, so what we need to do first is that we need to scale a by 2. So 2a is going to be 2 times 7, comma 2 times 4. And what that is going to give us is it's going to give us 14 and 8. All right, now let's scale b by 1/2. Right, so if we take 1/2 of b, whoops, 1/2 of b, that's going to be 6 times 1/2, which is going to give us 3, and 3 times 1/2, which is going to give us 1.5. All right, so now I have my new a and my new b. So if I subtract the two from each other, I'm going to have 14 minus my new 1/2 b, which is 3, comma 8 minus 1.5. And that's going to give me a new vector of 11 and 6.5. All right, so when you do these problems, make sure that you apply the scales first to get your new vectors, and then subtract. Okay, so you're going to follow the same operational order that you would if this was regular algebra. All right, now you guys know how much I love robot arms. So let's look at a robot arm. So let's say that A has horizontal component 3.1 and 1.5, right? So that's 3.1 over, 1.5 up. And let's say that B has horizontal component 1.4, so that's 1.4 over and 2.4 up, right? So even though B doesn't start at the origin, right, that just means that from the end of B we would go 1.4 over and 2.4 up. All right, so let's answer some questions. All right, so we're asked to find the position of the hand. So what that means is, let's go ahead and let's label this hand C, right? So to find the position, they want us to find the horizontal and vertical components of C. Okay, so how are we going to do that? Well, I know that the hand goes over 3.14 or 3.1 and then 1.4 more to get to here, where B ends. And then I know that it goes up 1.5 and then up 2.4. So what this is going to be, remember, if we connect the tail of A to the head of B, right, then this length C just equals A plus B. Okay, remember that little trick? Okay, so if we connect the tail of A to the head of B, we're going to get C, which is A plus B. All right, so to find the new position of the hand, we have A equals 3.1, comma 1.5, and B equals 1.4, comma 2.4. So then we're going to get that A plus B equals 3.1 plus 1.4, comma 1.5 plus 2.4. All right, and that is going to give us 4.5, comma 3.9. Right, remember I said A plus B is the same as C, so C is my new hand position, or is the hand position, I should say. All right, so that is where C resides. Which makes sense, so that looks like about 4.5 over and 3.9 up. So I'm going to say that that's pretty good. Now I'm asked, how does the position change if A is doubled, so if A doubles its length and B halves its length? Okay, so what they're asking is, what does this look like if I take A and I double it, but then I take B and I halve it? Okay? So pretend that A and B are hydraulic arms, right, so that it can extend and go down. So now they want to know, what is my new position of my hand? All right, so let's go ahead and calculate that out. So if A doubles, that means that I'm going to have 2 times A. And if B halves, then I'm going to have 1/2 B. Now remember, the position of C would be A plus B. So in this case, I have 2A. This is 1/2 B. So my new position of C is still going to go from the tail of 2A to the head of 1/2 B. So my new C is still going to equal 2A plus 1/2 B. So let's go ahead and calculate this out. So remember, first I'm going to find 2A. So 2A, I just double all the values of A. So 2 times 3.1 is going to give me 6.2. 1.5 doubled is going to give me 3. All right, and then 1/2 B is just having the components of this one. So 1.4 halves is going to give me 0.7. And 2.4 halves is going to give me 1.2. So if I add these together, right, I'm just adding the horizontal components together and the vertical components. So when I add them together, I'm going to get that 2A plus 1/2 B equals 6.2 plus 0.7, comma 3 plus 1.2. That's going to equal 6.9, comma 4.2. All right, and this is my new C value. All right, so let's see if that looks kind of like our picture. Okay, so notice in our picture that the horizontal component of A was 3.1 and it doubled, right? So that makes some good sense. The answer we got, which is 6.9. And also our new vertical component is 4.2. Now if you look at this picture, right, our vertical component was 2.4, but because we extended this guy out, right, and moved it up, then 4.2 also makes some pretty good sense. So I say that our answer does match our picture pretty good. All right, now let's get on to some how wind works. Okay, so this weird lingo only only pertains to wind. Right? So a north wind means that it's coming from the north. All right, so we use this a lot in weather forecasting, because if we say that we have a north wind, that typically tells us that we have a cool wind coming in, right? And temperature affects weather, so that's important. So if we have a 15 mile per hour north wind, that means it's coming from the north, which means it's actually heading the opposite direction, which is south. Okay? So then if we have a 30 mile per hour southeast wind, that means it's coming from the southeast, but it's actually heading toward northwest. So it's actually heading towards the opposite direction. Okay? Also, something to note is that if I draw north, south, east, west, that I know that the angle between north and east is 90 degrees, right? So between north and east is 90 degrees. The same thing with all of the other directions. Okay, and then the reference angles between, for example, northeast and north is 45 degrees. And that's true between northeast and east, or between east and southeast, etc., southwest, and also northwest. All right, so if I wanted to find the angle created between, let's say between north, and let's go ahead and go from north to southwest, right? I know that that's 1, 2, 3 45-degree angles, or one 90-degree angle plus 35 more. So then the angle created between north and southwest is 135 degrees. All right, so that's going to be important in our next example. All right, so let's have some fun with some airplanes. So let's say an airplane is flying with an angle of 50 degrees and a speed of 300 miles per hour. If a west wind of 30 miles per hour occurs, find the new direction and speed of the plane. All right, so we have a plane that is flying with an angle of 50 degrees. So instead of using bearing, I'm just going to use standard. So 50 degrees is right here. All right, and I know that the magnitude of the plane is 300. So I'm just going to denote the plane by P. So I know that the magnitude of P is 300 miles per hour. Great. And now I have a west wind. All right, so that means that the wind isn't going to the west, it's coming from. So we're going to start from the center, and it's actually going to be heading east. And let's denote the wind by W. I know the magnitude of the wind is 30 miles per hour. Okay. Now, what I really want to do is that I want to find the horizontal and vertical components of my plane and the wind. So to find the horizontal and vertical components of the wind, or my vector v, it's pretty simple since it's lying right on this line. I know that its horizontal component is 30 because it's moving 30 over. And I know that its vertical component is 0 because it's lying on the y-axis. All right. Had it been going west, then its horizontal component would have been negative 30. So if it had been an east wind, which means that it's heading towards the west, it would have been negative 30. But since it's going east, it's going to be positive 30. Now to find the horizontal and vertical components of the plane is a little bit trickier. So remember that we want to find P1 and P2, right? Well, if we remember from our notes, right over here, we know that cosine of theta, right, is going to be P1 over the magnitude of P, and I know that sine of theta is going to equal P2 over the magnitude of P. Right? So I know my angle, and I also know my magnitude, so I just need to solve these two for my P1 and my P2. Okay, so if I solve this for P1 and P2, go ahead and do it on some scratch paper. Alright, then I'm going to multiply both sides by the magnitude of P, then I get the magnitude of P times cosine of theta, gives me my horizontal component. Same thing for sine, I'm going to multiply by the magnitude of P. I'm going to get that P sine of theta equals P2. Okay, so if I go ahead and plug in the values I have here for that, just going to write them right down here, then I get that P1 equals my magnitude, which is 300, times cosine of my theta is 50, my P2 equals my magnitude 300 times sine of 50 degrees. Okay, so then I can write that my plane vector is going to be 300 cosine of 50 degrees, comma 300 sine of 50 degrees. Now you can put this into your calculator and round it if you like. Okay. So if we go back to our picture, we're asked to find the new direction. So we want to see how the force of wind affects the plane when the forces are added together. Okay, so what we're going to do is that if we add wind to our plane vector and draw the new force, okay, I'm going to call this new vector P plus W. Alright, so to find P plus W, we're going to add our components of P to our components of W. So P plus W is going to be 30 plus 300 cosine of 50 degrees. And 0 plus 300 cosine of 50 is just 300 sine 50. Alright, so now we have enough information to actually solve what they're asking for. So they want us to find the new direction, and they want us to find the speed of the plane. So let's actually start off first by finding the speed of the plane. Alright, so remember that speed is going to be the magnitude of P plus W. Right, so the magnitude of that is going to be the square of 30 plus 300 cosine 50 squared plus 300 sine of 50 squared. Okay, if you enter this into your calculator, what you're going to get is that you're going to get, whoops, not 360, we're going to get 320.1 miles per hour. Alright, so what this wind actually did was it actually speeded up our plane by quite a bit, 20 miles per hour, right? which actually doesn't do us any good because it's kind of pushing us off course anyway. But if you've ever been driving in a car and had a strong wind push you to the side of the road, you definitely felt an increase in your speed. Okay? All right, so now, let me just write down the information that we have about P plus W. So we have that P plus W is 30 plus 300 cosine 50, comma 300 sine 50. Right, and then we know that the length of P plus W is now 320.1 miles per hour. Okay, now how do I find the new direction? Well, if I were to draw this out, right, so this is P plus W, then I know that the length of this is 320.1 miles per hour. I know that my horizontal component is 30 plus 300 cosine 50. And I know that this component here, my vertical is 300 sine of 50. All right, so then if I wanted to solve for theta, I could do it a multitude of different ways. Okay, so what I'm going to do is that I'm going to go ahead and do tan inverse. So I'm going to take tan inverse of my side opposite, which is 300 sine of 50, over my side adjacent, which is 30 plus 300 cosine 50. All right, now when I plug this into my calculator, what I'm going to get is I'm going to get that that is about 46 degrees. I'm going to round up. Okay, now be careful and make sure that you graph these things, because what if instead of my angle or my new vector being this, what would have happened if my new vector had been in quadrant 3? That is when we need to use reference angles to adjust, right? So make sure that you're checking to make sure that your answer fits your picture. So in this case, since we're in quadrant 1, then this angle indeed would be about 46 degrees. All right, so this is very useful when we have weather or other variables that affect our travel that we can adjust accordingly. You've also seen that in section 8.2. Right, and that concludes the extra exercises for 8.3.